So it's it's Mother's Day. It's May something 2019. We're working on the originating sender for the #1 crossbar, and we found a bunch of problems with it. And one of them is that the relays are all really mashed up and gross. So we're gonna fix that. Astrid and I did a couple of them yesterday on Friday, and now we're gonna do a bunch more. So we got here Exhibit A. Broken wires, broken terminals on the back. And then this one right next to it, where my finger is, was really screwed up, but we fixed that. So this one here, L5, is what's going to happen next. So what we're going to do is remove the leads going to it, label the leads going to it so I can put them back where they belong with as little thinking as possible. And once the leads are removed, we're going to take the relay out and repair it, if at all possible, then we'll put it back in. So let's get started on that. So while we're waiting for the iron to warm up, let's talk a little bit about this project and what we're doing and why we're doing it. The apparatus we're working on here is a subscriber sender for our #1 crossbar switch. So what is that? The subscriber sender is the part of the switch that accepts dialed digits from the caller's telephone, stores them, we say it registers them. When it has enough digits to make a decision, it reaches out to the originating marker, which is a separate frame, separate apparatus. It then asks the marker to perform a translation and set up a talk path. Once the marker's done that, it tells the sender you're ready to go, and then this subscriber sender will then proceed to outpulse the call setup information to whatever the receiving switch is. So if we were making a call from a #1 crossbar to a #1 crossbar, this subscriber sender would register digits from the dial, call in a marker, marker would connect up a path to the terminating office, then this sender outpulses the call setup information to the terminating sender, which receives that. Our #1 crossbar, when we got it here in the museum, we had 2 subscriber senders. There's 1 and 2, which I know are out of frame right now, you can't really see them. This is number 3. So the important part about this one is this actually came from Brooklyn, New York. We drove this back here in a van a couple years ago. Why is it special? Well, the 2 subscriber senders that we do have are new style. They were replaced. They were replacement senders in the 1970s. So these were not the type of sender that was originally equipped in this switching machine when it was new in the 1940s. These are replacement units. The cool thing about this sender that's in front of me is that this is an original style subscriber sender from the correct time period. So it is more representative of what the switch would have originally had. Why did they replace the senders? That's a great question. The newer senders have additional capabilities that the older senders did not have. First of which is they can accept touch-tone dialing. The old sender can't do that. The newer senders can also accept additional digits for long-distance dialing and handle all that stuff. Old senders can't do that. The new sender can outpulse MF, multi-frequency. The old sender can't do that. So there's just a bunch of updates that happened between the 1940s and the 1970s, and to add all of that on to the old style senders was just not cost effective. There wasn't enough room in this cabinet. It would have required extensive modifications. So what a lot of the local telephone companies elected to do was say, screw it, we're going to just take out the old senders, we're going to use these newer ones as a drop-in replacement. They're the same size, they fit in the same mounting plates, but they have a lot more capability, a lot more capacity for all these new features that we're coming out with. So these old senders were taken out, they were trashed, new senders were dropped in. Our #1 crossbar, when we got it here in the mid-80s, the old senders were long gone, and we only have the new senders. So why do I want the old sender? Well, I think it's cool to be able to show both. I think the old sender is a lot more representative of the technology that was around when this switch was brand new, and just aesthetically as well, it looks like a lot more correct for this era of technology. So being able to demonstrate both the old behavior and the old appearance and the newer replacement behavior and replacement appearance, totally cool in my mind to do. This type of project has not been done before, as this is the only #1 crossbar left in the world. You know, this type of work is kind of unique, somewhat unprecedented, so I think that's really cool too. That's really neat that we're getting to dive into these circuits and be the first ones to touch them in, you know, a ton of years. And there's just not really an instruction manual for doing what we're doing, so it's exciting to, you know, to be in unknown territory. So that's where we're at. My iron is hot, so it is time for me to pull out this gross relay here, and these.
How are you today?
These pins are broken. I'm good, Chuck.
I mean, usually the thing is people have ADCs that are this big.
These pins up here are okay, but the two down here are going to need to be replaced. So we will remove these screws and then unsandwich the relay, and then hopefully replace those contacts. What is this? This is a, oh man, Andrew, you were right. That is ugly. Alright, let's do that. Alright, so when I last left off with you, we were going to fix a relay that was broken, and we did that. Now, I didn't tape it because it was a long, arduous, and to be frank, pain in the ass process. It took about an hour of me slowly and carefully working it apart and repairing it, and that would have been its own video. But we fixed the relay, took an hour to an hour and a half, put it back in the sender, which took another half an hour, and then I hooked all the wires back up, tested it, and it looks good. So that means that the sender now is pretty much ready to go. There's a few things that are still wrong with it, but I'm banking on the fact that my idea is that most of the things that are wrong with it are non-critical, meaning there are still things that are missing that might need to be replaced or fajorgled around, but they're not completely critical to the basic operation of the thing. So let's move on to hooking up the test frame. Okay, why do we want to hook up the test frame? Because rather than try to get it wired into the CO, to the crossbar as a whole, which is going to be non-trivial, I'll put it that way, non-trivial, it would be better first to be able to test it and test each portion of its operation and identify suspected failures before we just go full 9 yards on it and get it wired into the crossbar. Now, the test frame itself, I'm going to try to explain to you what we have to do. Now, the the user manual for the test frame is this. This is the CD, it's called. So I won't be able to explain the entire test frame to you. But what I can do is try to explain it briefly. So, let's say we have our sender in the middle here. This is what we're working on. And the sender has some inputs from the subscriber side of the switch, and then it has maybe some outputs over here to the trunk side, and then it also has some input outputs to and from the marker. And finally, the sender test, which is the frame we're working on. So the sender's sitting in the middle of this bunch of circuits, and keep in mind I am way oversimplifying. And we want to hook up the sender test frame to the sender so that we can poke it and figure out what it wants. Well, there's a bunch of wires to be run here. These wires between the test frame and the sender itself, I've already run them, so we're good there. But that's not all that the test frame wants. The test frame also wants to be able to talk to a frame right here, right in front of the sender, called SSL or OSL, depending on who you ask. This is the subscriber sender link, and that's what chooses a sender from a group of a bajillion. So the test frame wants to know that, can it reach out to the subscriber sender link, and can it kind of get that subscriber sender link to do what it wants it to do. The sender test frame also needs to be connected to the originating marker, because the sender test frame wants to be able to check the communication between the sender and the marker and make sure that it is what it expects it to be. So there's more wires. And the sender test also needs to be hooked up to a bunch of miscellaneous leads that I'm sort of glossing over right now because it would just be too much to go into all of it. So we have this. Check. And we need to do this, probably this, and a bunch of other stuff that we will find out as we go along. As it stands, we have more questions than answers. Because I forgot to mention just before I put the markers away, I don't know to what extent these wires are already run. I have wires from the subscriber sender link to all of the other senders, which are not pictured here. But I don't know if in that existing form, do I have enough unused leads to run from the subscriber sender link to the new sender that we're working on, or do I have to run a new cable? So that's a question. Other question is, I don't know if I'm going to have to run a new cable from the sender test to the subscriber sender link. I know there's leads that have to go there. We might have enough spares in an existing cable, but again, I don't know. And I suspect that this junk from the sender test to the marker is already run, although I could be wrong about that. So what we need to do is look through this CD and the appropriate drawings, and then climb up into those frames and see what has been run already, what I can steal from, and what I have to run completely new. As just because of the way we do things here, I try to use already existing wiring whenever possible. In this case, I want to use existing wiring whenever possible because I want to conserve cable. We have some 25 and 50 pair cable, but we don't have an infinite amount of it, so I don't want to run a new 25 pair unless I absolutely have to. So we will try to conserve existing cable first before I start running new cable. Let's go do it. Okay, went through the wires, checked, tons of drawings, ran the frame through a couple times to see where it was halting, and it looks like what we have to run are a specific set of leads between the subscriber sender link frame and the actual sender itself. So it's in this group. So I pointed to this, but I was wrong. This is already run, because the sender test frame is reaching the link okay. And I can tell that because looking at the lights you can see where the status of it is. But the link is unable to reach the sender, which makes sense. So we need, I believe, 8 leads between the link and the sender, plus a few extra, I think maybe 4 control leads outside of those 8. So we're looking at about 12 leads back and forth. I'm just going to run a 25 pair. And then hopefully what we can do is then use those extra leads later on when we have to. And then the next thing besides that is while I'm up there crawling through the cable trays in the top of the switch, I'll go ahead and run some extra leads between the sender and the sender make busy frame, which is an auxiliary frame over here. Those have to get run anyway. They're not required right now, but I might as well just while I'm up there just get it over with. And then once we've run these leads, we can then go back and run the test again and see if it's either going to advance and we're going to move forward, or it's going to still get stuck at this position, which means I did something wrong. So then we'll just do some debugging and some troubleshooting. So I think this about wraps it up for tonight. I was able to get those wires run, which is great. Not all of them, but I did get the wires run for the sender make busy frame, which allows me to A, make a sender busy when I need to, B, and get a lamp indication when the sender is busy or stuck, and C, an unintended impact of running the wires was lighting up a new lamp that shouldn't even be lit in the first place. But that happens at the museum sometimes. You run some wires and all of a sudden you get random lamps or bells that shouldn't necessarily be running, but hey, so I gotta figure that out, but that's not a big deal. Next thing on my list, probably for tomorrow or next week, is to figure out this craziness. This is the sender link frame, and its job is to link a subscriber line to a sender circuit. And as you can see, it's got these set of crossbar switches, and the line comes in on the vertical, and the senders go out on the horizontals here in the secondaries, and it is complicated because there's also this big controller cabinet to my left that I need to figure out how the logic in here actually works. I mean, I have a vague idea, but a vague idea is not quite enough when you're trying to make it actually work. So I essentially have to turn my vague idea into a proper understanding of the circuit, and then run some wires from up there, across the cable tray, into the sender, and cross my fingers. So we'll see you in the next segment, and hopefully get some more stuff done.